Thank you. So, good afternoon, everybody. Good afternoon, good morning, and good evening. So, respected distinguished delegates from WMO, SCAP, and PTC member countries, disaster managers, forecasters, media, and academia. At the outset, I welcome you all on behalf of RSMC New Delhi, India Meteorological Department, WMO, and PTC. And to this year, we are celebrating 50th year of formation of WMO SCAP panel on tropical cyclones. To commemorate this event, we have planned lots of activities. We'll be organizing a popular lecture series. Every Monday, we'll have one lecture from the PR of respected member countries, and we'll be organizing this competition. We'll be releasing a special issue in TCRR. We'll organize various national conferences at the member countries and an international conference also. So I request Dr. R.K. Chenamani, Head RSMC, to please present the welcome address.
Thank you, Madam Monica, and on behalf of good afternoon and good evening, everybody. On behalf of RSMC New Delhi and IMD, I welcome all our participants today in this 50th anniversary, the first lecture to be delivered by our respected Director General, Dr. M. Mahapatra. And as you will be very happy and delighted to know that in today's lecture we have almost around 130 participants, and it is being also in the YouTube live and also jointly with the IMS also. So this is a very big occasion, and in fact in 1973 the RSMC Delhi also operationally started its work, and for delivering the cyclone service for Indian region and also all the panel member countries. So till during 1973 we have only 6 countries, but now we could reach up to 13 countries, all the member country in the North Indian Ocean. And also, as you know, that we have also started as a WMO for severe weather forecast guidance for the region also. That also we have been doing since 2015. So without taking much time, once again I welcome all of you, and as you know that the best would have been the celebration, as today we are getting an opportunity, none other than the cyclone man of almost this North Indian Ocean, and one after another cyclone we have been successfully predicting. So as you know, the lecture itself, as has been the name of the lecture, title of the lecture is that the cyclone monitoring and forecasting over North Indian Ocean. So I invite all of you to please, see each and every point, the speaker, the expert, and then we will deliberate on it. Thank you. Yeah, thank you. Thank you, Monica. Yeah.
Thank you, Dr. Chenamani. Since this is the first lecture series we are organizing and we have Dr. Peng with us, so I request Dr. T. Peng, WMO, to please speak a few words on this occasion.
Thank you, Dr. Sharma. First, thank the ISMC New Delhi to initiate to leading the serial lecture for commemorating the 50th anniversary of the panel on tropical cyclone. And then I wish also to thank the Dr. Mahapatra to take the kickoff lecture for so. And as you all know, Dr. Mahapatra actually gave the lecture presentation every time in the PTC attachment training. So his lecture is well known and also very informative to all of us. And then also I wish to welcome all of you to participate in this very informative lecture. And we in the WMO, we will fully support any possible activities. But to be honest, nowadays, in my side, during the change the workload, so I now have less time to contribute to the PTC, but I still try my best to do that way. So in the future, we will for the PTC, we will try not only for the meteorology, but we also need to do something for hydrology and DR at this time. Many disaster managers are also here.
Sorry, Dr. Peng, you are not audible.
Okay, sorry.
Yes.
Yeah. Anyway, so I was not audible from the beginning.
No, sir. Just now.
Okay. Okay. Anyway, and for the sake of time, I just stop now. Thank you very much.
Thank you, sir. Now I request Dr. Sanjay Kumar Srivastav, SCAP, to please speak a few words on this occasion.
Thank you, Monica ji. We are all waiting to listen, especially none other than our friend Dr. Mahapatra, the journey of PTC in from almost half a decade. So it's a historic moment to look back and also to look forward. How PTC could be what we call a cyclone ready North Indian Ocean. So I'm just looking more excited to hear from Dr. Mahapatra and all the PTC community. So thank you very much. This is a brilliant idea to, especially for 50 years of PTC, looking back and looking forward, and then make sure that how we can prepare the North Indian Ocean basin a cyclone ready. So thank you, Monica ji. Thank you, colleague, and thank you for this opportunity.
Thank you, sir. Now I request Dr. Muhammad Shamim Hassan Bhuiya from Bangladesh Meteorological Department to please introduce the expert speaker.
Thank you very much. With your kind permission, I am Dr. Shamim Hassan, meteorologist from Bangladesh Meteorological Department. It is very much honored to introduce Dr. Mahapatra. He is today's speaker in this lecture series. Dr. Mahapatra is the Director General of Indian Meteorological Department and third Vice President of WMO. Dr. Mahapatra is PhD in physics and has a vast experience of 30 years in meteorology. He earned laurel of the region from various international and national agencies like WMO, UN, UNHCR, WMO ESCA panel members, Honorable Prime Minister and President of India, and Chief Ministers of coastal states for effective cyclone warning services. He is popularly known as the Cyclone Man of India. He has authored more than 125 research papers, edited 5 books, 13 reports, and 7 journals. He is recipient of honoris causa DSc from Odisha University of Agriculture and Technology, FM University, and Kalinga Institute of Industrial Technology. He is the Fellow of Indian Meteorological Society and Indian Climate Congress. He is recipient of Young Scientist Award by Ministry of Earth Science and Archives Award 2013 for excellence in cyclone warning services. He has been facilitated by various governmental and non-governmental organizations for his contribution in cyclone and other severe weather events monitoring and forecasting. He has played a significant role in improving the early warning services in the region, has enabled the disaster managers to minimize the death toll due to any cyclone to less than 100. He is chairman and president of various international and national committees associated with improvements in severe weather warning services, including tropical cyclone, monsoon, thunderstorm, and lightning. He has made significant contribution in capacity building in the region with organizational delivery of lectures during tropical cyclone forecasting training since 2005. We welcome you, sir, and request you to present the first talk in the popular lecture series organized as part of the celebration proposed to commemorate the 15th anniversary of WMO ESCAP panel on tropical cyclone. Thank you, sir.
Good morning, good evening, and good afternoon to all of you.
Good morning, sir.
I thank all of you for being present in this auspicious occasion to celebrate the 50 years of WMO ESCAP panel on tropical cyclones. With the 50 years of WMO ESCAP PTC, a regional specialized meteorological center for tropical cyclones also came into existence. So thereby, SMC New Delhi is also celebrating the 50 years of its establishment and providing the services in the region. I thank our colleague from Bangladesh for introducing me with so many adjectives which I may not be deserving for. So thank you very much for your excellent introduction. At the outset, I congratulate all of you, especially the WMO, UNESCAP, members of WMO ESCAP panel on this auspicious occasion of 50 years of the PTC. I also thank all the permanent representatives of 13 countries for coming together to celebrate the 50th anniversary of WMO ESCAP panel on tropical cyclones. Am I audible?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
And am I visible? Slide is visible?
Yes, sir.
The first slide is
First
coming.
slide, sir. Only first slide now.
That's right. Is it moving?
Yes. Yes.
Yes.
Yes.
Fine, thank you. So today I'll just go to the timeline in the past 50 years. And I'll be discussing about the evolution of cyclone monitoring and forecasting system over the North Indian Ocean. So we talk of the tropical cyclones. Certainly, it is analogous to the development of the science of cyclones, globally and specifically over the North Indian Ocean. If you remember, in 1737, when there was an unprecedented storm surge and lakhs of people died, at that time perhaps nobody knew about the tropical cyclones and its name, its characteristics. But over the period of time, with the knowledge gained by the society, contributed by the scientists and our predecessors, at present the world is able to understand the various aspects of the tropical cyclones, its vagaries, its adverse impacts, and also the world has come up with the tools and technology to deal with all these vagaries and minimize the loss of lives and properties. I'm just presenting here some of the facts based on the WMO document, which narrates about the impact of tropical cyclones during the past 50 years, starting with 1970. As per this report, 33% of the hydrometeorological disasters are caused by the tropical cyclones. And 1 out of 3 events that killed most people is the tropical cyclone. And 7 out of 10 disasters that caused biggest economic losses in the world are tropical cyclones. And it affects many countries, especially 85 WMO member countries are affected by tropical cyclones. So it's also death due to tropical cyclones. We had the notorious record that 300,000 people died in Bangladesh in 1970, and it's still ranked as the biggest casualty. Out of 80 tropical cyclones developing worldwide, only 5 develop over the North Indian Ocean. And out of these 5, there will be 3 to 4 making landfall over the different countries bordering Bay of Bengal and Arabian Sea. But however, cyclone monitoring, forecasting, and warning services deal with all the modern tools and technologies, and hence, as and when there has been intervention of new tools and technology, that has been tested with the tropical cyclones. And that's why there has been significant improvement in monitoring, prediction, and warning services for the tropical cyclones worldwide, and here, of course, in the south, in the Bay of Bengal and Arabian Sea region. As all of us know, that a tropical cyclone is associated with multiple hazards. You can expect the storm surge, that is abnormal rise in seawater leading to inundation of the coastal areas. There could be the combination of the storm surge to cyclones, the local tides, there could be waves and swells, and therefore there could be a combination of the various causing factors leading to the total water enveloping the low-lying areas of the coast. There could be the gale winds leading to the majorly the structural damages. It can also cause damage to ourselves in terms of injuries and loss of lives. And also it causes the loss of power and communications, houses, buildings, and vegetations, and also the crops. Rainfall at the same time leads to contamination of the supply system, land subsidence, inundations or flooding. There could be riverine flooding, there could be coastal flooding, there could be urban flooding. If it is hilly area, there could be also landslides, landslides, mudslides, and mudslides. The important point is that all these hazards occur simultaneously. Therefore, cyclone is a multi-hazard scenario. If you just remember 1970, this is the day we should remember 1970 Bola cyclone, which is the deadliest cyclone so far. On the left-hand side diagram, you can see the track of Bola cyclone, and you will find that it developed over the South Bay of Bengal and moved northeastwards and crossed Bangladesh near Bhola and caused the havocs. In the middle, it is the image indicating the eye wall spiral bands of the cyclone Bhola, and you can see the damages caused by this cyclone. We don't know actually. At that time, the press and electronic media was not so efficient. It is very difficult to find out the exact number and the exact amount of loss which occurs. Even now also sometimes we miss it. But what I want to say, it was an enormous loss to the humankind. It is not the fact that Bangladesh was affected, but the entire region was affected. The region was surprised and thought of taking some actions. The world body also came together and thought that we should take some actions after this cyclone 1970. In the memory, you will find that there has been many super cyclones. Total, you can find 6 super cyclones developing so far. And I'll just mention another super cyclone, 1999, which gave another wake-up call for the scientific and disaster management community of the state and the country and the region after the devastating cyclone of 1970. In between, of course, we have got 1990 super cyclone affecting 91 cyclones affecting the eastern coast of India. So here also 10,000 people died. You can just see and imagine what the havoc caused by the cyclone from time to time. There could be immense loss of lives and properties which may not be possible to be counted even after the disasters. The world body has come up, as I was telling you, since 1970. And if you look at present, there is well-defined disaster risk reduction processes involving various international organizations like United Nations, World Meteorological Organizations, National Meteorological and Hydrological Agencies. And through this process, we have come up with the national policy and international policy for management of the tropical cyclones. We have come up with the National Disaster Management Act, favored national disaster plans, national guidelines, and also the institutional mechanism. As all of us know, that tropical cyclones needs intervention by each of us as a scientific community, the disaster managers, during the disaster, before the disaster, and after the disaster, in terms of the preparedness sections, response sections, and relief and recovery actions. But while doing all these actions, you will find that multi-hazard early warning system plays a key role. It is the first and foremost which can minimize the loss of lives and properties. The MSEWS instigates the disaster managers and general public to take the response sections to minimize loss of lives and properties. This multi-hazard early warning system has come up a long way over the years, and you will find that each and every country has improved all the components of multi-hazard early warning systems, which may include the observations and also the various modeling systems, forecasting, early warning, and disseminations. I'll just like to work over the memory lane, evolution of the institutional mechanism. As I was telling in the beginning, 1737, this is the storm surge height of 30 meters due to cyclone over West Bengal. You can just imagine how many people would have died during that period. In 1876, the storm tide of 12.5 meters over Bangladesh, Bakergunj cyclone. In 1970, Bhola cyclone, where 300,000 people died in Bangladesh. In 1971, 10,000 people died in Odisha due to cyclone that crossed Paradip and affected entire northeastern coast of India, including Odisha, West Bengal, and to some extent Bangladesh. In 1972, considering all these things, there was a hue and cry. WMO and USK panel came together and established a panel on tropical cyclones with 6 members: Bangladesh, India, Myanmar, Pakistan, Sri Lanka, and Thailand. Maldives joined in 1982, Sultanate of Oman in 1997, Yemen in 2016, United Arab Emirates, Saudi Arabia, Qatar, and Iran in 2018. So thus, by today, we have got 13 members of this WMSK panel on tropical cyclones. The first session of the WMSK panel on tropical cyclone was held in January 1973 at Bangkok, Thailand, with 6 countries. In 1973, also, India Meteorological Department was designated as Regional Meteorological Center, and it got renamed in 1988 as Regional Specialized Meteorological Center for Tropical Cyclones. In 1990, considering the devastating cyclone, Machilipatnam cyclone, 1990, the Cyclone Warning Directorate was established in New Delhi based on the cabinet decision. And in 2023, that is 2003, the RSMC Tropical Cyclone New Delhi acted as also the Tropical Cyclone Advisory Center to provide the guidance to the international civil aviation community, including the meteorology offices in different parts of this region. If you look at the institutional mechanism as of now, we have got 6 RSMCs, and RSMC New Delhi covers the entire North Indian Ocean. Earlier, the area was limited. It was north of 5 degrees north and also up to 60 degree east in the west. Then, of course, gradually the area increased, initially from 60 degree to 55 degree east, then 50 degree, and now it is 45, and then the 40 degree east, up to which we are covering the tropical cyclones and depressions developing over the region. Similarly, it was covering up to 5 degree north, and now we are covering up to equator. So, along with the responsibilities RSMC Tropical Cyclone New Delhi and TCAC, we also provide the Global Maritime Distress Safety System bulletins on life to ensure life at sea to be safe and secure in the case of the tropical cyclones. Now, just looking at the various components of the cyclonic system, you will find that just like any other weather event, it starts with the observations. And as all of us know that tropical cyclone is a vast synoptic system with a size of 100 kilometers to 1,000 kilometers and extending up to a height of 15 to 18 kilometers. So it needs three-dimensional observations, and we go for that with surface observations, upper observations, and also the space-based observations from geostationary satellite, polar orbiting satellites. So there has been evolution with respect to all the components that we'll see in terms of observations. So all these observations are at present utilized to define the initial condition of the atmosphere and ocean, and hence the initial condition of the weather systems prevailing of the day. At the same time, all these data are digitized and sent into numerical weather prediction models. We have got a set of numerical weather prediction models, starting with global models to regional models, starting with deterministic model to ensemble models. And all these models and hence the multimodal ensembles are utilized to prepare the forecast. And once this forecast is generated, then the subjective assessment and addition of the value was carried out by the video conferencing system, so that finally the end forecast is generated as an objective forecast generated by the set of numerical models and based on the observations collected from different platforms, which is modulated by the knowledge, experience, and expertise gained over the years and exchanged with the forecasters dealing with the tropical cyclones. And finally, the end forecast is provided in such a way that it can be utilized by the general public and disaster managers. I have to say that this end forecast is nothing but an impact-based forecast, including not only the forecast for the tropical cyclones, but also its impact in terms of the impact of heavy rainfall, impact of wind, and impact of storm cells. So as we provide this entire information, it becomes handy for the decision makers and general public to take a decision or actions. But apart from this real-time information and communication exchanged with the various stakeholders and disaster managers, there is also a role for preparedness, like the hazard and risk analysis. So, for example, guiding the disaster managers about the location of the cyclone shelters, the strength of the cyclone shelters, the preventive measures required, and mitigation measures required for the tropical cyclones. So with this, let us look at how did you start with in the beginning itself. I'm just talking about from 1737. Let us look at that era. What could have happened actually? Before 1864, the depression or feeble storm indicated in the area where barometric pressure was lower compared to surroundings. There was no such clear-cut definition of a low pressure area or the depressions or the cyclones. There was no quantification of the intensity of the low pressure systems. There was no specification of the area by which the low pressure should be defined. In 1864, Henry Peddington coined the term cyclone for tropical storms, and that was the beginning of the story, you can say, at least in this part of the globe. In 1908, Dallas classified cyclone circulations in Meteorological Atlas of Indian Seas and the North Indian Ocean as the cyclonic storms, that is, winds do not exceed force of 10 Beaufort scale, or you can say wind speed 55 knots or less. Then cyclones winds of hurricane force, that is 11 or more in Beaufort scale, it is 56 knots or more. And this classification continued for a long time. You will just look at it is continued after 1923. So for 15 years almost, this classification went on cyclone storms and cyclone. Then 1925, it's a Normand in Atlas of Storm Tracks in the Bay of Bengal stated that depressions may include all cyclone circulations ranging from those of small barometric depth and weak circulation up to the severe cyclone with its ring of hurricane winds and central barometric deficiency of perhaps 2 inches. So thereafter, in practice, it evolved and it was defined in 3 categories like depression, cyclone storms, and severe cyclone storms. So depression in the Beaufort scale, it is 7. Cyclone storm, it is 8 and 9. And severe cyclone storm, it is 10 and more. And accordingly, this is the definition of the winds associated as 33 with depression up to 33 knots, and cyclone storm 34 to 47 knots, and severe cyclone storm 48 knots and more. So this was the major intervention, I will say, in 1925, which categorized the different weather systems in terms of its wind speed and Beaufort scale. And this classification continued for a long time, 1925 to 1973. Even now also, if you look at the Web Atlas of India Meteorology Department giving the details of the cyclones, it discusses in these 3 categories only. Now, in 1974, there was intervention again. So you may think of why it happened so, actually. In 1974, geostationary satellite came into existence. And therefore, every 3 hours, you could find out some kind of assessment of the intensity and location of the tropical cyclones developing over the region. So therefore, the definition became more sharp, and we could come up with low pressure area, depressions, deep depressions, cyclone storms, severe cyclone storms, and severe cyclone storm with core of hurricane winds. That means the major intervention was to introduce another grade, that is severe cyclone storm with core of hurricane winds, which could be estimated with the Dwarak technique in 1974. I just want to say that Dwarak technique initially was thought of in 1967, but it could not come up. It was just taken as the assessment of the convective bands and the clouds, and accordingly intensity was decided by the forecasters. But 1972, the real Dwarak technique came into existence, and hence by 1974, it was applicable with the visual imageries only. Afterwards, what happened, I will see that. Now, in 1999, actually, if we just look at, before that, I just want to mention that during this period, 1974 to 1998, visual image interpretation came in 1972, and it was implemented in 1974 here, and we could find out the intensity based on the technique. But afterwards, in 1984, we came up with the IR-based Dwarak technique. So therefore, you can say that even I have written here 74 to 98. From 84 onwards, the intensity classification, even though category remains same, would have been improved further because of the availability of both visual and IR imageries. Because I just want to say, especially at night period, visual image is not there. So therefore, from 1974 to 1983, it could have been really underestimated or overestimated because you don't have any image at night. From 1984 onwards, you came up with the images from visual and IR. Therefore, at night, you have got certain tools based on the satellite. Now, in 1999, we came up with further classification that severe cyclone storm with core of hurricane wind category was further classified as very severe cyclone storm and super cyclone storm. Very severe cyclone storm became 64 to 119 and super cyclone storm 120 knots and more. So this was the first introduction in 99. And in 99, we had the super cyclone in October 99. So based on the annual cyclone review, we came off in 1998 to introduce the super cyclone category in 1999. So that you can just see how the system, we declared in 99 our super cyclone category, and the first super cyclone occurred in October 99. Now, thereafter, another intervention came towards classification in 2015. So then, people thought that, and DSM was told that your category of very severe cyclone storm extending from 64 knots to 190 knots is quite large. So you should have some kind of extremely severe cyclone storm. So we introduced extremely severe cyclone storm 90 to 119 knots, and that was in 2015. And at present, this classification is in vogue. Now, I just want to show you some examples. So this is the tracks of the cyclones based on the Web Atlas of IMD. On the left-hand side, this is the track of the cyclones and depressions during 1891 to 1960. And bottom one here, it is 1961 to 2020. So just at the first look, you can find that there was no cyclone 1891 1960 over the Arabian Sea. And 1961 2020, there are many cyclones extending towards the Arabic Peninsula, Somalia, etc. Is it so? So this comparison indicates that the estimation of the tropical cyclones and depressions of the Arabian Sea was highly underestimated during the pre-satellite era. The satellite came in 1961. To some extent, you got the polar orbiting satellite in 1960, April 1960, TIROS-1 satellite was launched by USA. And in 1963, USA donated automatic picture, just SRPT, high resolution picture transmission reception center, and it was established in Kolaba office of Maharashtra in Mumbai. And therefore, our monitoring improved, and you can see the tracks over the Arabian Sea, therefore. Similar is the case if I consider cyclone storm 1991, 1960 and 2020, you can find out the tracks are becoming more zigzag and it is more tracks and moving towards particular directions. We could find out what is details with the intervention of the satellite. Same is the case with respect to severe cyclones on this side. Now let us look at the during the satellite era itself. You can find out there is evolution of the classification and the intervention of the various types of observing systems. Say 1961 to 73, when it was only polar orbiting satellites, you see what is the number of cyclones of the Arabian Sea, and you can see even in the Bay of Bengal or Andaman Sea area and nearby. Now you see during 1974 to 1990, we have got the visual image and also IR image, so for geostationary satellites. So you can see how it is coming with. Okay. Then you can go to 2010, we have got the buoys, we have got the other observational systems in the Bay of Bengal, Arabian Sea. Then you can see 2011 to 2020, we have got all types of observational tools, including microwave, and also you've got ships, buoys, and automated stations, coastal stations, dense coastal observations, etc. And also the radar. All these observations certainly helped with the forecasters so that they do not miss any cyclones, at least near the coast and also over the sea area. And this is just an example of how the number of the cyclones and the frequencies, the average frequency is written here. So, for example, 1991, 1960, severe cyclones are 1.5, and then 2020, it was 2.2. So here, if you are working on climate change, you may be tempted to say that the number of severe cyclones has increased in recent years. But I would say otherwise, it could have been underestimated during 1890 to 1960. Therefore, this difference is 1.5 to 2.2. So therefore, what I want to say that the data period from 1891 to 1960, which is kept based on certain observations, are not perfect. So therefore, if we want to study the climate change issues, we should consider the data since satellite era. So this is another example of how there could have been the missing, there could have been the overestimations, etc. So this shows a comparison of the frequency of cyclone disturbances, the total number, and also the numbers excluding the short-lived cyclones. Short-lived cyclones are the cyclones which has got the life period of less than 24 hours. So let's see, for example, 1890 to 1900, that decade, total was 164. If I remove short-lived cyclones, it becomes 112. But if I compare now 1981 to 1990, the number is same, 190, 109. So what does it indicate? It indicates that there could have been the overestimation of the genesis in the shorter lifetime. So for example, today I have seen, I declared, but whenever it comes closer to the coast, I find that no. Then I downgrade it. Now it's not a cyclone. So it could have been there. So there could have been uncertainty because of the lack of tools at that time. Now, similarly, if I just draw the trend line, this is trend line 1891 to 2010. What do you find that if you consider all the cyclones, you'll find that there is a decreasing trend line. So that means you will say that number of cyclone disturbances are decreasing on North Indian Ocean. But if I remove those short-lived cyclones, which could have been overestimated or underestimated, then I find that there is no trend. There is no trend in the total frequency of cyclone disturbances. So therefore, the quality of data matters a lot. So I request the climate change community to be very cautious about data being used for the study of climate change and tropical cyclones. Now let us look at, as I was telling, that satellite played a dominant role from 1960. The first satellite came as the first US satellite, and it was launched by USA. So 1972 to 82, actually, we received the imageries from NOAA and NASA. The 1980 to 83, first generation INSAT program was started. Then 1996, actually, dissemination of satellite imagery started from IMD through website. So therefore, the international community, like WMSK panel members, got really benefited with the satellite imageries from 1996. Prior to that, it was going from, say you can say, through secondary data utilization centers, and it was being received by the countries. So 2002, we came up with the Kalpana, launched in 2003, INSAT 3A was launched. In 2008, we came up with fully automated indigenous development of the meteorological data processing system. If you remember MDD, and MDD was also established in different member countries of WMSK panel. Then in 2013, we came up with INSAT 3D, and 2016, we came up with INSAT 3DR. And at present, we have got two satellites, 2013 and 2016. In 2017, we introduced the rapid scan utility from the INSAT 3D imager. That means now, like the Himawari, like the GHOST satellite, INSAT 3DR is utilized to have every 6-minute scan of the tropical cyclones when cyclone develops over the Bengal and Arabian Sea. And all these rapid scan images are made available in the website for benefit of all the countries. In 2018-19, we came up with the new multi-mission meteorological data receiving and processing systems. 2020, it was made operationalized. So if we just look at now the current status, we have got INSAT 3D, INSAT 3DR. Every 15-minute images are available in the website. You can utilize the rapid system, which is a GIS-based system. You can find out your area, you can find out the convection, you can find out the location of the various weather systems. The polar satellites are also being used at present, and also about the scatometer from SCAT and OceanSat 3 at present. So you can just see this is again the summary of what happened actually in 1984 onwards, 2002, how we came up with basically image product initially, then we came up with the cloud products, the cloud motion vector products, then finally we came up with the outgoing ground radiation, sea surface temperature, quantity precision estimate, etc. Now you can find out that there are many products which are useful for day-to-day monitoring of weather systems. And we have got the 6th channel imager also in INSAT 3D and INSAT 3DR, and which are the resolution of 1 kilometer, 4 kilometer, and 8 kilometer. In whatever channel it is 8 kilometer, in the IR channel it is 4 kilometer, and visual channel it is 1 kilometer. So now this system is providing the real-time information monitoring of the tropical cyclone, not only tropical cyclones, but all types of severe weather events. Now let us look at the radar. So what happened actually with respect to history, if we just look at IMD adopted radar technology in 1950 with the establishment of X-band radar at Dum-Dum, Kolkata. The first indigenous X-band radar system was in IMD in 1970. It was established in New Delhi. The first S-band cyclone detection radar was established in Visakhapatnam in 1970. So it all happened actually in 1970, cyclone 71 cyclone. If you just remember, I was giving the previous slides, there was more than 10,000 people dying in Odisha, and there was another cyclone in Andhra Pradesh. So these two cyclones is called 10,000 each, led to a cabinet decision that entire coast should be covered by the radar. So by 1973 and 74, entire coast along the east and west of India was equipped with 11 cyclone detection radars. The dates are given here, and partially over the period of time, these cyclone detection radars are replaced by the Doppler radars. So what happens actually? The cyclone detection radar in 1970s beginning helped in detecting better up to about 500 kilometers from the coast into the sea, and therefore it helped in improving the lead speed of the forecast cyclones up to 48 hours. Prior to that, the forecast was limited up to 24 hours only. So this is the Doppler radar along the coast, the total 37 radars. What you can find along the coast, it is entire coast is covered with Doppler radar at present, and there's some of the statistics can be kept at distance. So similarly, there has been development of the surface observations. You can just see here, prior to 1877, we have only 7 observatories along the coast. And at present, if we just look at, we have got 77 observatories along the coast. I am not counting the automated stations. I am talking about the departmental observatories established by India Meteorological Department. It started with 7, pre-1877, and now it is 77. Similarly, if I look at the pilot balloon observatory, it came to existence with 2 numbers in 1911 to 20, and now we have come up along the coast 23. The entire coast is 60, entire India is 62. So RSRW observations, if we just look at, it was almost 0 up to 1950. 1950 to 60, we started 6 RSRW observations along the coast. The dates are written here in the diagram, and now we have got 19 RSRW observation stations along the coast, covering entire coastal belt. So this is the pilot balloon observations, RSRW observations, what I told you. And if you just look at their spatial distribution of the RSRW stations and pilot balloon stations. So this is the entire observational network that you can say that over the period of time, how we have improved over the region and also along the east and west coast of India. Now, if I just look at once you get all these observations, you have to communicate. Here also, I'm just discussing about what was the communication technique or the tools since 1970. If I just look at 1970 to 1974, we have the Philips system, DS714, which had the 2 circuits, and it could exchange only few kb of data. Speed was only 2400 bps, and type of data was alphanumeric, and machine was telegram. You just imagine, you can think about that. Even when I joined and I experienced what is a super cyclone, it was taking 6 hours to send the information to a district collector after the observations through telegram. So therefore, there was delay. People may think that the cyclone forecast at that time did not give forecast correctly, and that is not correct. Again, I will tell you, because even if they give the forecast correctly, that forecast correct cannot reach the general public and disseminate in time because of the communication system at that time. In 1988, we came up with the VEX system, so we got 8 circuits, and 3 MB data could be exchanged, and we started utilizing printer, telegram, telephone, fax, etc., and data type became the alphanumeric and scan files. By 2000, we came up with the Nexus system, where 4 GB data could be exchanged, and we came up with the VSAT systems also. In 2009, we came up with the Transmit, that is the modernization of the communication system, you can say, and there was no limit of the circuits, and we came up with 600 GB data exchanged, and with the digital platform, we could have the different modes like audio, video, binary, PDF, etc. And then, of course, we get 2012, the core system. So like that, the data exchange has improved, especially recent time, I will tell you, starting with the 2000s. And under the World Weather Watch, IMD is acting as a regional telecommunication hub and exchanging the data with different countries in this region, and also the regional telecommunication hubs of WMO. Now, this is a new phenomenon which WMO has brought out, that is WMO information system, and that is also in place in IMD. It acts as GISC for this region, and it helps in better communications and dissemination of the information to member countries and many more. So we also, there are other achievements also, just like, for example, APIs. You can find out number of APIs developed for the region, and people are utilizing APIs, and day by day, number of users are also increasing. And there has been a dedicated website that is mosam.imd.gov.in for general public, and also RSMC New Delhi for tropical cyclone purpose. There has been continuous upgrades of the internet. National knowledge network connectivity has been in place. There is a video conference system, social media, mobile apps are also in place for communication of the information. Now, once you have the data, you have to compute data, process data, utilize the data in the numerical representation models. So it has undergone also many changes over the years. The first supercomputer came into existence in 1994. Gone are the days in 1960s and 70s, we are just utilizing the punching the data, and we are utilizing the computer kept in some other institute like, say, Planning Commission of India, or the Indian Institute of Technology, Delhi. Gradually, we came up with our system in 1994, that is a supercomputer. Before that also, there were certain computing systems. Then second one came in 2009. Then third one came in 2014, and 2018 is the latest one, and we're going to upgrade again in 2024 or 2023. You find that it has come up with 10 petaflop machines at present. With this, So the number of numerical representation models started increasing. While in 1994, we got only the LAM, limited area model, we came up with now the GFS with 12 kilometer and weather resource forecast system with 3 kilometer, SWARF with 2 kilometer, NCOM and NCOMR 12 and 4 kilometers respectively. And also about the ensemble model GFS and EPS. And you will be surprised to know that with all these computing power, with the data of 5:30 morning, we can generate forecast from the models by 9:30 within 4 hours. In 1994, it was taking 24 hours to generate forecast for 2 days from the limited area model. Now, this is the various types of modeling system which is being used for tropical cyclone forecast. We have got at present 5 days warning for tropical cyclones, starting with genesis, then track, intensity, landfall, and associated adverse weather. For this purpose, we have got the multi-model ensemble, single model ensemble, and grand global ensembles. And all these ensemble forecasts are available from various sources and also in-house. We have got the global models, and we have got the regional models, and the nowcast models. So what I want to say that different models, you may be surprised why different models are being used. Different models have their own limitations and applications. So we have to utilize all the platforms. And for this purpose, we need a decision support system. And that decision support system has changed the story. As you can say, before 2010, we've got completely manual analysis of a tropical cyclone. Here you can find out cyclone approaching towards Myanmar. And after that, you can see 2010, you can say this is another cyclone 2010, which went very fat, cyclone fat. And it went close to Oman and then crossed near Karachi. You can find out that what paradigm shift in the standard operating procedure, the observational systems, modeling systems, forecasting, and early warning. So if I just look at how it is being done, actually we have got a decision support system for this early warning, monitoring, and decision making. And it has got the facility to compare, comprehend, analyze the various types of products, and take a decision, and also generate the products for dissemination. Now, with this also, we have come off a long way for the common alert protocols and various other tools. At present, you will be surprised to know in the cyclone Biparjoy, which crossed Gujarat and Pakistan between Karachi and nearby to Jakhau. And in that, the common alert protocol was introduced to provide warning to individual to the wild service providers. You will be surprised to know that we sent more than 5 crore SMS during cyclone Biparjoy to the state of Gujarat. 5 crores means it is 50 million. More than 50 million SMS was sent. So you can see that this is a success story, how the people are getting, and this message in the local language. So not only the common alert protocol, there is many other interventions for this purpose. We also come up with the GMAS system, global multi-alert alert systems. We give the warning to the WMO through that it goes to the entire country also. Now, there has been a number of advances, not only the common alert protocol, there has been the mobile apps for different purposes. There has been the NAVTEC system to go up to 450 kilometers. There is a mass media system, including the AM and FM and community radio, the private TVs. There has been social media. There has been video, text, audio, graphics, and other messages. So there has been communication tools like GAMS and NAVIC. GAMS is government messaging system. And NAVIC, as the name indicates, it is meant for the fishermen. Yes, for the sea areas. These two are the space-based communication system. It is developed in cooperation with Indian Space Research Organizations and the INCOIS and other sister organizations of IMD. So if you just look at the SOP evolution, say after the establishment of panel, there was major intervention in 1988 when it was dedicated as Regional Specialized Meteorological Center. In 1991, we came up with the first annual report on cyclone disturbances for North Indian Ocean during 1990. A consolidated report, it was also shared to all the countries and it is published. Now also it is available in RSMC website. In 1997, we started the publication of annual cyclone review, which takes stock of the 5 components. One is the meteorological component, hydrological component, then disaster risk reduction component, then research component, and the training component. So it takes stock of the work done and the achievements and the gap areas and the plans for next 4 to 5 years for the all member countries in this region. In 2004, we came up with Accordingly, we published the Tropical Cyclone Operational Plan. Also, every year it is published for this region. Then 2004, we came up with the naming of the cyclones. The first name was Anil, if you remember, it was Bangladesh name. And then in 2005, we came up with introduction of 2 weeks training for cyclone forecasters. This is the first intervention by the WNSCAP for the capacity building of the people. And from there, we are conducting every year 2 weeks training program, and that training program has undergone several changes over the period of time. In 2008, we came up with the Cyclone Atlas to make the data digitally available to the countries and the people so that research can be carried out, so that it can be utilized for climatological guidance. In 2008, we came up with another intervention, that is 72-hour track and intensity forecast with the cone of uncertainty. It started with the cyclone Ward in 2008 in December, which crossed Sri Lanka. So that was the beginning when we gave 72-hour forecast in objective format, indicating the track and intensity in a map. Then extended to 120 hours in 2013 and 168 hours in 2023 sometimes. In 2008, actually, media briefing from Cyclone Nargis commenced. We went for the press conference in a massive way from 2008. We started a forecast demonstration project along with all member countries, which is aiming at utilizing all the available data, observational and model products, and give the best forecast. That exercise started in 2008, and it was very successful, and it has helped in improving our SOP, improving our monitoring and forecasting process. In 2009, we came up with the storm surge guidance, and this is again, it was the cyclone Bijli which went to Bangladesh, and it was the first storm surge guidance for this purpose. In 2010, we came up with the quadrant wind radii forecast. It started with the cyclone Giri, which crossed Myanmar. In 2014, it was the dedicated website, as all of us know. And then also we came up with 2014, the introduction of the probabilistic genesis forecast for next 3 days, extended to 5 days in 2018 and 7 days in 2023. In 2016, we came up with the severe weather forecast demonstration project, where we provided the forecast for heavy rainfall, the wind, the storm surge, the waves, etc., apart from the tropical cyclones. Extended range forecast for cyclogenesis was introduced, valid for next 5 days, valid for next 2 weeks. Every Thursday it is issued since 2018. Then we started with the quantitative tracking intensity forecast from the depression stage from 2018. Earlier it was given from deep depression stage. In 2020, we came up with the cyclone tracking intensity forecast in GIS. You can find out your area and the track and intensity. So again, also the second list of names of cyclones was introduced in 2020 with 169 names from 13 member countries. In 2022, we introduced the pre-genesis tracking intensity forecast. All of us should feel proud. These are some of the interventions which is first in the world. Pre-genesis tracking intensity forecast started from the stage of low pressure. And then 2022 also we started with customized location-specific forecast for offshore industries, online offshore industries. It was given in purpose forecast, color-coded format to each and every industry in the Bay of Bengal and Arabian Sea. The indigenous development of DSS. We have a well-defined decision support system in IMD at present, which is developed within the IMD. We have also the automation generation of bulletins. We have adopted all the techniques and tools so that it can be more perfect, it can be more timely, and it can be error-free. So we also came up with web-based dynamics composite risk atlas for cyclones, hazards, and quantitative loss estimates. It was operationally introduced in 2023, but experimentally started in 2021. So what we do then? In this, we provide the loss forecast. We provide the number of electric poles to be uprooted. We provide the number of houses to be damaged. We provide the area of agricultural field to be affected. And it's also converted into the rupees, Indian rupees. And that provides different information to the government to know what is the expected loss. And accordingly, the immediate response, recovery, relief actions can be taken up by the government. And we're happy to know that Government of India nowadays, before the cyclone, sends money to the concerned state government for the preparedness measures. Also, we introduced a multimodal impact-based forecast for severe weather in the region in a GIS format. So this is just an example. I'm telling the comparative parameters. Whatever story I told you, if you say the cyclone forecast has undergone 12 phases, or you can say 12 versions. The first phase will be 1865 to 1876. You will see that very limited service at that time. Then 1877 to 1890, then 91 to 63, 1964 to 73, 74 to 83, So these are all with the intervention of the new tools and technology or new methods based on which this period has been defined. And we can find out that with this intervention gradually, the error has decreased. The PC center location detection error, if I say, during 1877 to 1890 was about 275 kilometers. And if I say cyclone is located in X1, Y1, latitude, longitude, there could be an error of 275 kilometers in the location itself. So forget about the forecast. I'm not talking about the forecast. And there is no forecast, of course. And this reduced to 200 to 150 kilometers by 1963, by end of 1963, you can say. And gradually it went on decreasing with the satellite era. And at present, in detection of the tropical cyclone center, there is an error of about 10 kilometers. If I look at the forecast accuracy, you will find that there was no such forecast till 1997. And there was qualitative forecast. There was no quantitative forecast. It is very difficult to find out. I just took an example of cyclone in 1998, which caused death of 4,000 people in Gujarat. They found that the error was about 155 kilometers. And it was very difficult for the disaster managers to take actions, as the areas covered about 500 kilometers to say where the cyclone will cross. But gradually, if we just look at it, it has come up to track forecaster has come down to 63 kilometers for 24 hours, 91 kilometers for 48 hours, and 164 kilometers for 72 hours in 2021 onwards. So if I just compare the average track forecaster for different versions in the recent time, say in 2003 to 8, average error was 155 kilometers. From 9 to 12, if I look at it, reduced to 136 kilometers for 24 hours. It became 93 kilometers in 2013 to 17, 76 kilometers from 18 to 20. Now it's 63 kilometers from 2021. So what you find that because of the technology intervention, because of the improvement of our standard operating procedure, because of the development in numerical modeling, observations and collaborations and cooperation among the various researchers, developers, and the practitioners, there has been significant improvement across the time scale. Now, I will not take much time. So this is just an example. I'm just telling how we have come up with. I have just discussed so many things, but it is there in this person. The network of observations, what is the forecasting system and 1970s and what is at present. We have got only one satellite, 1963 polar orbiting satellites. You got once a day or sometimes one image which may cover or may not cover the cyclones. But we have got now two satellites covering every 15 minutes the entire globe. Therefore, you can find it. There is no polar orbiting satellites for a long time in India, but now we have got. So missing rate could have been very high before the satellites, and now we have got similar the radars. We came up with only one radar in 1970, that is Visakhapatnam cyclone, and now we have 37 radars in the country, covering 84% of the total area of the country, and also the neighboring regions of the development countries. Similarly, if I just look at the genesis, yes, there has been there was no genesis forecast, and monitoring was quite poor, and with a lot of error, as I showed you, about 250 kilometers. But as of now, you see there are a lot of tools and technologies available for genesis monitoring, and we have gone for forecasting also up to 15 days. Genesis forecast is being provided every Thursday, and every day we are providing genesis forecast for the next 7 days. And for this purpose, there is a number of numerical modeling, genesis potential parameter, then coupled forecasting system based on the in-house ensemble system, and also the various international agencies. So if you just look at, if I compare, for example, the landfall point estimation error, where I'm not talking about the forecast error, I'm talking about the estimation error. Because the number of observations are quite less, the estimation error itself in the west coast is 140 kilometers. And east coast is 105 kilometers by 1890. By 1940, it reduced 97, 93, roughly 90 kilometers, you can say. By 1960, it became 55 kilometers. And by 2010, it is 25 kilometers. If I say that cyclone has made landfall at point X, the error is about 25 kilometers. But by 2020, I have not written here, we have got enough radar system, therefore error is about 10 kilometers. If I say the center is here, that could be an error of about 10 kilometers. So similarly, if I look at the location monitoring, you will find that there was no such system where satellite observations came up in 1970 with surface observations limited. But now, if you just look at it, there is a number of observational tools. Similarly, if I come to the forecast, there was No numerical modeling, only climatology, analog, and persistence was in use. Now we have got that about 10 models, we have got satellite, we have got radar, synoptic methods, and we have got the high performance computing system. Similarly, if I just look at the forecast validity period, it was up to 24 hours in 1970. Now we have got up to 120 hours, indicating the objective track intensity, landfall, etc., and associated adverse weather. And accordingly, if I just look at the recent period, so it is reduced from very high error to very limited error. Similarly, if I just look at the intensity monitoring, same is the case. At that time, it was completely dependent upon the synaptic analysis, whatever SIP that are available, or coastal island stations that are available. The satellite though came, actually, the Goddard technique was not available. The technique came in 1972, finish of the technique for visual image only. Therefore, you can just imagine in this 1970 also, it was not so efficient observation or monitoring system for track and intensity. But now you have got everything to provide 24-hour forecast, to provide forecast up to 7 days, and also 24-hour forecast average about 7 knots only, when it was about 25 knots error at that time. Now, if we look at the rainfall monitoring, it was limited run gauges at that time, whereas you have got now multi-satellite run gauge, you have got the run gauge and satellite merged data set, you have got GIS-based tools to identify your rainfall, you have got high resolution satellite and radar information. And similar rainfall forecasting, at that time there was no such tool. You have to depend on the climatology, on the analog of the system, and accordingly you can say the synoptic method was used for rainfall forecasting. But now you have got quantitative precision forecast available from various models and multimodal ensemble and global ensemble also. The accuracy was quite poor, but now if I compare what is the accuracy of predicting heavy rainfall, it is about 78% 24 hours ahead over a particular district or a particular region. So by that way, there has been a lot of improvement with respect to other parameters like storm surge. At that time, there was limited tide gauges. You cannot monitor exactly what the tide is during the cyclone period. So therefore, it was the post-cyclone survey only which decided what is the storm surge. Then you came up with the nomograms, but quality of accuracy was not so high. And gradually we came up with the coastal inundation model. We are not providing only the storm surge height, but also coastal inundation with the ERSAT model. And there is about 80% improvement in recent 5 years compared to previous 5 years in the storm surge forecast and guidance. Now, similarly, if I just look at the various steps of prognosis and diagnosis, at that time, there was no such prognosis and diagnosis, very limited. It was not communicated to various agencies. Only the inference part, one paragraph is mentioned. But at present, you'll find that we are writing prognosis and diagnosis of all observations and model guidance. It is available to all the disaster managers and also the scientific community for their forecast. We have come up with district-wise impact-based forecast, GIS-based warning, dynamic composite risk assessment, coastal flood, inundation modeling, storm surge inundation modeling, flash flood guidance also has come up, and high-resolution wave models are also being used with the help of NCOIS. Now, if you look at the advice action suggested, yes, at that time historical damage was limited, but in 1992 we came up with some damage potential published by IMD, which was used for different categories of cyclones based on the historical impact, and that was continuing till 2020. And from 2020, we are utilizing dynamic composite forecast, dynamic impact-based forecast, utilizing the web-based risk atlas, and also the number of stakeholders are being provided very specific information at present, utilizing all this. So I want to say that there has been overall information improvement in terms of the genesis, track, intensity, landfall, and its communication, associated adverse weather. And it has been possible because of the improvement in all sectors, be it observational tools and technique or be it modeling. And there has been a very good collaboration within the Ministry of Earth Sciences. We have got IITM and NCERT who work hand in hand with IMD, and also we have got NCOIS for the web and structured purposes. Also, there are many academic and R&D over the region who is work together, and WMSK panel countries also work together with the RSMC so that all the information are provided timely. We thank all the member countries for their cooperation in improving and evolving the cyclone forecasting running process over the years. It is a seamless flow. You can see here, temporal scale starts with 15 days, then goes for 5 to 7 days forecast, then 3 to 5 days forecast, then next few hours forecast. And frequency also, it goes from say every Thursday, then goes to daily, then goes 6 hourly, then 3 hourly, then every 12 hourly forecast. And it provides all information associated with the tropical cyclone like track, intensity, structure, landfall, adverse weather, damage, and also we include the response sections. This is the warning process. You can say that we provide the forces warning for the disaster managers, pre-cyclone watch, alert warning, post-landfall outlook, and also we've got very specific 13 types of bulletins are issued for specific users so that action can be very timely. Now, this is just a SOP of the cyclone warning. I just gave an example. With an example, I'm explaining you the SOP of the cyclone starts with the beginning of the season. It starts with the pre-cyclone exercise. And this is an example in April, we took a pre-cyclone exercise in a particular year, 2021. And then it is followed with the extended range outlook every Thursday. Then you come up with the mid-range forecast, indicating probability of genesis for next 5 to 7 days. Then they come up with the formation of low pressure area. A special message is issued with the formation of low pressure area. Press release is issued, press conference is organized. Then you go for step 5, pre-cyclone warning, 372 hours in advance. Then you go for cyclone alert, then cyclone warning, then landfall, etc. And nowadays, it has become an end-to-end system. We have developed a movie also based on that with the suggestion from WMO. It is an end-to-end system. That means the early warning is coupled with the early action. This is just an example. The highest authority, Honorable Prime Minister of India, communicates, discusses, and takes decision and inspires everyone in the country to take action when warning is issued by India Meteorological Department. And now this is just an example of the latest utilization of the impact-based forecast for winds, floods, and coastal inundations. You can see these diagrams and these tables, how we are calculating the various exposures, losses expected, like agriculture, building, essential facilities, transport, utilities, etc. Not only in numbers, but also in rupees, and the loss effect expected because of the floods, loss affected because of the wind, loss affected because of the storm surge, and total losses. On the left-hand side, that was the historical damage expected. What we use on the right-hand side is the dynamic risk atlas-based information provided to common people. It is at the village level. You can just imagine. And last cyclone Viparjaya, it was used by the public. So that if I just compare as a benchmark, I've just compared the National Hurricane Center. If I compare the forecast of extended forecast we are issuing, they are also issuing up to 2 weeks. Medium range forecast we're issuing up to 5 days, they're also issuing for 5 days. We also have the probability forecast, they also have the probability forecast. Objective track forecast, we are providing up to 120 hours, they're also providing for 20 hours. Now, if I just compare the track forecast errors, I have just taken the 3. One is what I want to say that we are not lagging behind any RSMC in the world. I put up here one of the best RSMC, that is National Hurricane Center, USA. And also here is a comparison of the forecast accuracy of the Japan Met Agency, that is RSMC Tokyo, then National Hurricane Center, that is RSMC Miami, and of course RSMC New Delhi, that is India Meteorological Department. So if I look at, you find that the forecast accuracy is quite good of North Indian Ocean. It is better than sometimes the different international agencies. Similarly, if we consider the intensity forecast, we find that accuracy is quite good and it's comparable or better than these international agencies. Okay. Now, with all these, I will say that the success story, you can see that the last figure, extremely severe cyclone storm Viparjaya, having the death 0. So that was the, if I remember in 2013, when I went for cyclone filing briefing to the cabinet secretary in the National Crisis Management Committee. So there he told that we should aim for 0 casualty. But however, at that time, 22 people died. It is almost, you can say, it is reduced from 10,000. Cyclone Filing was it was almost equivalent to super cyclone, and death was only 22 compared to 10,000 earlier in 2013. And that number, if you just look at gradually, it has gone down, and you'll find that there is no such cyclone where the death has exceeded 100. So this is the case of India. Now, if I go to case of the WMSK member countries, also you'll find that the number of deaths has decreased quite significantly. And considering the recent cyclone Mocha, you will find that yes, both Bangladesh and Myanmar, number of deaths has been quite less as compared to the previous cyclones like 2008. We will find that number is significantly reduced. It is impossible given the response action by the disaster managers based on the early warning provided by the WMSK member countries. We provide the advisory. Now, challenges. If I just look at the challenges, still there are certain science gaps in this region. If I just look at detailed internal structure and dynamics of the cyclones in this region is not known. We do not have the aircraft reconnaissance in this region. Therefore, it is very difficult to find out what is the internal structure. We have tried for that, but however, to some extent, microimageries and radars are helping us to understand the structure and dynamics. The ocean atmosphere land interaction due to lack of adequate observations and modeling capabilities. That what I am to say that even though we have improved in all aspects, but still there is scope to improve our observational systems to have a coupled model involving the ocean, atmosphere, and land surfaces. We have coupled with ocean and atmosphere, but we have to go for ocean atmosphere land interaction. That it will be done by the coupled model. The intensity forecast is still a challenge, especially the rapid intensification near the coast or rapid weakening near the coast is still a challenge globally, but here also it is a challenge, and we have to do more for that purpose. The rate at which the track forecast is improving, landfall forecast is improving, the intensity forecast is not improving in that rate. It is slow improvement. It is because the intensity depends upon the internal structure. It depends upon the internal core structure. So therefore, we have to go for observations and its physical processes and understanding of physical processes and the parameterization in our models so that we can have the better intensity forecast. Then we can go for the gap in observation systems. We just look at, yes, we have the observation systems, but it is not adequate. We have to go for further improvements. For example, we can have the new technologies like high wind speed recorders. We've got 35 wind speed recorders in the country, but we can go further to other countries also in the region. And no aircraft for AV reconnaissance is available at present. Spectrometers, you can say that only one spectrometer is launched recently. No ground-based mobile platform is available, and there is lack of microwave satellites for this region. We are all dependent upon the others. So modeling system, as I was telling you, there is limited probability information of the landfall, heavy rainfall, wind, and storm surge. It has just begun in recent times. We are improving it in terms of developing extreme forecast index, etc. We have to still go a long way to develop and further improve this one to have the location-specific higher accuracy. And artificial intelligence and machine learning can play a dominant role for this purpose. Geospatial technology, it has been used so far, but if you look at it, it has got very low resolution digital elevation model. We have got very limited socioeconomic attributes. We can come up with the impact-based forecast system for the entire region here. IMD is willing to handhold the technology. We can develop the DSS for this region, but we have to improve our socioeconomic attributes. It is developed by the country itself, and also the digital elevation model from the satellites has to improve further. Otherwise, you have to go for down batting. Warning dissemination, yes, we have come up with common protocol. At present, we have common protocol only in terms of SMS. We have to go for audio, video, text, graphics, etc. And there is therefore still scope. There are still regions where you cannot reach out. Nothing and games are playing in space-based communication system to a large extent. But I will say that we have to go a long way because in this region, if you just look at apart from India, other countries also, there are many dialects. The information should go in dialects, it should go in the language of the user. So therefore, there is still scope to improve so that we can minimize the loss of property apart from the loss of lives. So I think with this, I will stop here. So thank you very much for listening with patience. Now you can have the questions.
Thank you, sir.
هو طالبنا لما دخلنا
Any questions you can?
You can put your questions also on the chat box if required. And I am also taking questions from the live streaming from YouTube. So I'll be pasting the questions in the chat box.
Sir, you are not audible.
بس عملية الدخول صعبة.
Yes, please.
دخلنا تأخرنا شوية بس كان ضايع علينا الصوت ولا دخلنا في ساعة.
صوت مليح.
Can you please repeat the question?
Sir, am I audible?
Yeah, you can speak loudly. Yeah.
Sir, it's an excellent presentation. You have mentioned in your presentation that NKN. Oh, sorry, sir. I am Shoji Hossain from Bangladesh Meteorological Department. You have mentioned in your presentation NKN, National Knowledge Network. Is it only for meteorological purposes or any other purposes you use it, sir?
No, it is being used for many purposes in the country, but we utilize for our purpose. This is the communication. All types of communication can be carried out through this National Knowledge Network.
Thank you, sir.
Sir, I have a question, sir.
Yes, please.
So I just, when you were showing the monitoring part, particularly the detection right from the pre-satellite and then radar plus satellite and like that. So do you feel that still the, any part of the cyclone is missing in the monitoring, sir?
Yeah, there was an example I will tell in 2006. There was cyclone Agni. This cyclone Agni could not be detected by satellite in its genesis phase. It developed near east coast of India, the southeast coast of India, very close to coast, and satellite could not detect it. But it was detected by radar in Chennai. So therefore, there are certain occasions where you can have miniature cyclones, that is small size cyclones, about 100 kilometers, 150 kilometers diameter. In such cases, sometimes satellite cannot detect. So therefore, radar helps in that direction. So therefore, whenever there is no radar, if it is the mid-sea where the cyclone is of miniature type, that is size is about 100 kilometers, 150 kilometers, there could be certain, considering from the experience what we saw in 2006, there could be certain misses by the satellite when the cyclone size is quite less. So therefore, we should utilize all the observations, all the informations in a complementary manner so that nothing is lost. That is the only case I have come across during my monitoring period. So therefore, with the satellite, the number of missing has been significantly less, except those mini cyclones which are not picked up by the satellite. Radar has helped a lot to avoid any missing near the coast within, say, 500 kilometers.
Thank you, sir.
Dr. Sarfaraz and Dr. Peng has raised their hands.
Yes, please, Dr. Sarfaraz.
Dr. Sarfaraz, you may ask your question.
Sorry. Thank you, sir. Thank you very much for your excellent presentation. Just a very simple question that the naming of tropical cyclone has started in this region from 2004, as you mentioned. So the cyclone Bhola, how it was given the name Bhola? And later on?
Yeah. So prior to naming of the cyclone 2004, usually we remember the cyclones in terms of the point where it hit the coast. So it is the Bhola Island where the cyclone hit the coast in Bangladesh. So therefore, it is called as Bhola cyclone. Similarly, we called Paradip super cyclone in 1999. So that was the process at that time. But those cyclones which developed the sea and did not cross the coast, they did not have any name. Only Bay of Bengal cyclones and Arabian Sea cyclones. So therefore, there was no such naming procedure at that time. Yeah.
Thank you.
Thank you.
Dr. Peng. Dr.
Okay,
Peng
Dr.
has
thank
also
you,
raised
Dr.
hand.
Yes, Dr. Peng.
Thank you, Dr. Mahapatra. I'm not asking a question, but a comment. Was further thank you for the excellent presentation, and basically you covered many things, particular history of the PTC, which I hope I can say something. But I think now from after your presentation, I need to talk about that later on. And one comment, I created the SharePoint folder, and which will be all the presentation will be gathered, and I already sent an email to Dr. Sharma, and later on all the presentation will be collected and will be uploaded there. And currently, I have already uploaded the video produced by IMD with the leadership of Dr. Mohapacha. Honestly, this is the excellent video, and I think except the historical part of what Dr. Mohapacha presented today, and for the rest of things he presented today already included in the video. And I think this video is also included in my understanding, and I think also many of my colleagues agree. Included basically all the essential 4 elements or 4 pillars of the UN-wide new initiative on early warning for all. I think this is really something, as a good reference for members for each country to, if they wish to develop or establish a national early warning for all, then this is a good reference for you to have a watch it. So I already uploaded in the folder, and this folder will be shared later by Dr. Sharma. Thank you.
Okay. So there is a question in the chat box. What is view on contribution of AI-based prediction of TC? So there are many papers published and saying they are 90% accuracy. Yeah. So it is a new intervention coming up in recent time that artificial intelligence and machine learning can play a role in providing genesis forecast, track forecast, intensity forecast, associated adverse weather also. There are many research papers coming up. But for this region, that is North Indian Ocean, no such concrete development has taken place so far. People are working in their directions. One institute is collaborating with IMD also for development of the AML based tools for cyclone forecasting. So all are welcome. If any knowledge is developed that can be practiced in this region, we are always welcome to the new knowledge, new tools and technology. It will certainly benefit this region. So,
yeah, sir, I have a small question, sir.
Yes.
Yeah. So that as you mentioned in the pre-satellite area or early satellite area, the frequency of the Arabian Sea particular sequence, the frequency of Arabian Sea cyclone is it very less because of the underestimation, or what are the reason is yeah.
That's what I wanted to show, that there was no estimation because you would not have tool, and in the Western Arabian Sea and also the Central Arabian Sea. Therefore, the numbers are quite less. So therefore, if you consider data from 1891 to 2020, certainly you will get a rising trend. So therefore, I suggest those who work on climate change, they should consider the data from satellite era only, 1960, and please find out. And that we have done. We have seen that 1990 onwards, there is an increase. If you consider data of 1960 onwards, there is an increase in frequency of extremely severe cyclone storms over the Arabian Sea. So we did not consider the data from 1891 onwards. It will refer, our paper is there in motion. So this is one thing. The second thing is that there also could have been sometimes the overestimation or sometimes the underestimations, because we do not know. We depend upon only one shape or two shapes, whatever resolution should get. Therefore, quality of the data in terms of the frequency, in terms of the intensity, will be certainly either overestimated or underestimated before 1960. So that we have seen. One example I took, the depression case. When you remove the number of depressions with number of cyclone disturbances with life period less than 24 hours, there is no such significant trend in the frequency of cyclone disturbances. But when you include it, it shows that there is a decreasing trend in depressions or cyclone disturbances. So therefore, it is the data, how judicious you are to decide the quality of data, the period of data, period analysis, that will decide the results of the analysis.
Okay.
Okay. There is another question here that is it possible to get your lecture? Yes, it will be circulated. You can get the lecture. Because the duration is more than 2 weeks, what causes the cyclone for so long duration? Yeah, there are instances when these cyclones can be longer. If I compare different ocean basins, the cyclones we have seen the longest in the Pacific. And also Atlantic has also longer cyclones because the area is larger. When you consider Bay of Bengal Arabian Sea, area is smaller. Therefore, we do not have many longer cyclones, but still we have, if it is extremely severe cyclone storm, super cyclone storm, on the average, it will be about 5 to 7 days. So in this particular case, Viparjaya also, it was longer because cyclone is moving very slow. Because of the slow movement, because of the fact that cyclone is moving in the favorable sea area and favorable atmospheric environment, it could maintain its intensity, it was not weakening, and hence it was longer. So basically, if I look at the total track length, it is not so high. But if you look at the total life period, it is quite high. So therefore, if you just look at the speed by which it was moving, it was roughly about 7 kilometers per hour. The average wind speed is about 13 kilometers per hour. So that is one of the most important reasons why it was longer. Then you may ask why it moved slowly. It is slowly because it was sandwiched between two anticyclonic circulations. And it was not allowing the system to move faster. Okay. So there is
PR of Oman, Dr. Abdullah Al Khadouri is with us. He is raising his hand, sir.
yes, please.
Yes.
Dr. Abdullah, yes, please.
Yeah, thank you, Dr. Mohabatra. As usual, very comprehensive and excellent lecture, well informed. Thank you very much. I don't have any question, but I would like to take this moment and occasion to say thanks to the WMO and all member countries, PTC member countries, really for the hard working and for all their efforts for the last years. Now we are celebrating 50 years of PTC, and this is really a accomplishment for nowadays. See how we were in 1972 and how we became right now, and that in sake of saving lives and saving and decreasing the economic loss from destructive tropical cyclones. That's what I want to say. I don't have question. Very informed lecture, Doctor. Thank you for this opportunities, and thank you for all these activities in celebrating the 50th annual celebration for the PTC, and looking forward to increase and to enhance also all cooperations between the members. Really, we need such good cooperations to elevate all the member countries to be also well prepared for the tropical cyclone dangers and hazards. We need to do that for all member countries. As for the big initiative that supported by WMO, early warning for all. So we would like to also looking forward to enhance this cooperation. Thank you again, Dr. Mohabbat. Thank you, everyone. Thank you.
Thank you very much. Yeah.
Mr. Mustafiz from Bangladesh.
Thank you, sir. Sir, am I audible?
Yes, please.
Okay, thank you, sir, for your nice and excellent presentation. It was very informative for us. We came to know many things regarding tropical cyclones, sir. I have no question, but I have some proposals, sir. In your lecture, you mentioned, sir, that to know the structure and dynamics of tropical cyclone is very important to forecast accurately. That's why, sir, I think that if we comprehensively do any attempt regarding to knowing or to diagnose the tropical cyclone at any time with all the country members, then of course it seems to me that it would be better to trace, to forecast any tropical cyclone accurately, and we can save our life in any member countries more accurately. So my proposal is that, sir, under your leadership or under IMD leadership, taking all the countries members together, we can have a plan to how to improve the forecast of tropical cyclones, sir. Thank you, sir.
Thank you very much for your suggestion. We will work together. We'll find out what could be done further. Thank you.
Sir, I have one question.
Yeah, Anand, yes.
Sir,
Yes.
Climate change, we know that it has impact on the frequencies and intensity of the cyclones. But my question is, sir, whether climate change is having any impact on the characteristics of the tropical cyclones in our region, sir? Like the interaction with environment or the interaction with the oceans, anything is changing the behavior of the cyclones, sir?
Yeah, it is a very interesting question. I'll tell you, this is the topic of research. There are very limited studies are there with respect to the structure of the cyclones and dynamics of the cyclones. Whether structure is changing or dynamics is changing, there are very limited, not only for our ocean basin, but also the entire globe. If we just look at the studies are very much limited. There is quite good number of studies with respect to the frequency, genesis, and characteristics like, say, trend in wind shear, trend in vorticity, or trend in divergence, or trend in genetic parameters. But with respect to, say, structure, whether it is changing, whether moisture flux is changing, that is a very limited, or the mass field is changing, that is a limited study. But one thing is there that it is been studied that what happens to the rainfall associated with tropical cyclones. Yes, it has been studied and found out that there could be increase by 10 to 15% in the intensity of the rainfall due to the cyclones. So it is mainly because of the global warming, and as all of us know that in the tropical country, when cyclone is approaching towards a particular coast, there will be additional impact of the global warming. The higher the temperature, higher the capacity of the atmosphere to hold the moisture, and that moisture holding will lead to more intense rainfall activity. Similarly, with respect to the storm surge, it is also, there is another study by the way, Saab and others, that there could be increase in storm surge by 10 to 15%. So it is mainly because that there is a sea level rise, and that sea level rise is a continuous process. It is not felt on day-to-day basis, but when there is a cyclone moving towards the coast, the sea level rise will interact with the storm surge by the cyclones. And also you can consider that since the intensity of cyclone is increasing certain bands, but of course in our area only Arabian Sea intensity is increasing, so in that case also that will increase by 10 to 15%. So therefore storm surge can increase by 10 to 15%. But intensity of cyclone Bay of Bengal is not increasing, it remains same almost. Total number of cyclones is decreasing over the Bay of Bengal. Total number of cyclones Arabian Sea remains same. So there are enough scope to study it further and find out the further details of the impact of the tropical cyclones on the tropical cyclones.
Thank you, sir.
Okay, I think there is no other questions. So you can go for.
Hello.
Sir, Dr. Oman DG Med se or Dr. Kotal, and again Dr. Sarfaraz.
Yes.
Yes, Kotal ji, Dr. Kotal.
Thank you very much, sir, for your excellent presentation. I have never seen such a informative lecture on cyclone. So again, thank you very much, sir. My question is, from real-time forecasting, we have seen for recent two cyclones. One is Asani, and recent into there is 22, and in 23 there was Mocha. For Asani, there is a intensity forecast normally challenging, but for Asani it was good forecast. But track was very challenging because before most of the model was showing before landfall it was recurved towards northeast. Whereas in the case of Mocha, landfall was very excellent. Landfall forecast is much improved, but intensity it was most of the models showing high underestimated, particularly for the very sophisticated model like ECMWF. So in real time, such a challenge, how you can handle in real time? It's a very challenging for the forecaster. Is real time. How you can handle?
Yeah, thank you, Dr. Kotal ji. पहले तो I want to congratulate Dr. Kotal. He has done a lot of study on various dynamical statistical modeling over this region. So we have come up with every stage some dynamic. One I just discussed here, like GPP, where he has worked for. Another I discussed about the MME, multimodal ensemble, where he worked for. So by that way, we also came up with a decay model over the land process. So we have come up for each stage, we have come up with dynamical statistical modeling by the SMC, especially Dr. Kotal has contributed significantly. Apart from that, the problem what he has discussed, the cyclone Asani, which was moving towards east coast of India and near on the west coast, yes, intensity forecast was a challenge. It was a challenge. It weakened before landfall into depression, but at the same time, track was very tricky. Yes, there are certain difficult tracks. If you look at the recommendations of the last IWTC, you will find that still the track forecast is challenging and difficult tracks are still encountered when there is looping, when there is sudden change in the track, when there is slow moving, when there is rapidly moving. These are all problem areas. And what is most intriguing is that in cyclone Asani, most of the numerical models also failed to detect that type of track, and therefore error of the RSM's New Delhi was quite high. So it was a lessons learning. That means we cannot say that track forecast is perfect. We have to still work for all these difficult cyclones. It needs prognosis and diagnosis to find out what parameter went missing in the numerical modeling system for which it could not detect it. It is a very good case study. But thing is that you also need the observational data, and unfortunately, you don't get observational data in the cyclone field over the oceans. However, whatever limitations are there, I request the research community, they should analyze all the difficult cases and bring out such solutions, how to improve further the accuracy of these recurving cyclones, looping cyclones, fast-moving cyclones, slow-moving cyclones. I will tell you, we did a study. There is a finding that track forecast error is about 20% higher in case of all these difficult cases compared to the straight moving cyclones. Okay. So, yeah, I think, yes, there is a question that.
Can you hear me?
So DG Met
Yes,
Oman.
sir.
Yes,
Thank you, Dr. Mohapatra, very much for this excellent presentation. As you know, I have one question. As we know that there is a very lack of sea surface observations, especially from Arabian Sea. Is there any idea to establish and support from WMO to do more of sea stations in Arabian Sea more than in the future? Thank you.
Yeah, thank you very much. Actually, yeah, we can request WMO to examine and, if possible, to improve the number of buoy observations, shapes, or coastal observations for the Arabian Sea region, which will take care of this data sparsity and also the impact of the climate change on the tropical cyclones. So thank you very much, sir. Thank you.
Thank you very much. Thank you very much for your efforts.
Yeah. Thank you.
Sir, am I audible, sir?
Yes.
Yes, and thank you, sir, for your nice presentation, very informative. I am Shara Sultana from BMD. I have a work on of cyclone disturbance on 30 years using your data and our data. But I observed over there, cyclone disturbance is of Bay of Bengal is decreasing, but severity is increasing. My question is that what are the reason behind it? Sir, if you have any comments or anything.
Yeah, if you remember, Professor Manabe was given Nobel Prize, and his hypothesis at that time became true. Therefore, the entire world recognized Professor Manabe. the impact of climate change and tropical cyclones. If you just look at, what is happening over the years, that sea surface temperature is rising and oceanic content is rising. That means sea is becoming favorable for more genesis. But the mechanism which you find for genesis of the tropical cyclone, that is called as conditional instability of second kind, which warrants that you should have sufficient moisture with relative humidity more than 50% in the middle tropospheric level. But the trend shows that this moisture in the middle tropospheric level is not increasing, it is decreasing. So if you do not have moisture in the middle tropospheric level, certainly it will not be helpful, the system mechanism will not be helpful for genesis of the tropical cyclones. So Professor Maneva suggested at that time that as a impact of climate change, the temperature in the lower tropospheric level will increase, but temperature in the middle and upper tropospheric level will decrease, and that is happening. So this phenomena does not allow the more genesis of the tropical cyclones. Therefore, there is a trend in decrease of the frequency of tropical cyclones. But at the same time, once the cyclone genesis takes place, the environment becomes moist. The moisture increases in the middle troposphere. And therefore, once there is genesis, there is possibility for intensification. Therefore, rate of intensification is increasing, and hence the intense cyclones frequency is increasing, though the total number of cyclones are decreasing. Am I clear, madam?
Okay, thank you, sir. Thank you.
Thank you.
Hello, am I audible?
Yes, please.
Yeah.
Yes.
It's Manal El Hashmi from Sultan of Oman. Thank you, doctor, for this wonderful and informative presentation. I just have a quick question regarding the artificial intelligence, where we know that artificial intelligence is massively growing and nowadays and making miracles in many sectors. I was wondering if you have implemented any kind of tools using artificial intelligence operationally, or you have any plans to do so in order to increase the accuracy of the forecasting. Thank you.
Thank you. I have replied this question earlier. Yeah, artificial intelligence is coming up for application in cyclone genesis monitoring, intensity monitoring, and forecasting of track, etc. But so far, we have not operationally used the AML technique. There are some collaborative work with IMD and certain research institutes in the country for application of AML in genesis forecast and also in the rainfall forecasting, etc. But so far, it is not implemented. It is an open field of research, and if any data or any product is needed to be shared by IMD, we will share it. The various groups should come up for analysis and development of the tools based on AML.
Thank you. Am I audible?
Yes, sir. Yes.
Yes, sir. Thank you very much for your excellent and informative presentation regarding the tropical cyclone over North Indian Ocean. My question is, you are following the different NWP models regarding the cyclogenesis and also track of the cyclone. So which model is, every model has some uncertainty also. In spite of uncertainty, which model gives more reliable result for genesis as well as the track of the cyclone? Thank you.
Thank you, Dr. Raman. It is a very tricky question, but I will try to reply. What we do in RSMC is that we consider multimodal ensemble. So we consider about 10 models. Out of 10, best 5 models we consider. Best of that 5 models, we prepare a multimodal ensemble. There are 2 multimodal ensemble. One is the weighted multimodal ensemble, and another is the simple average multimodal ensemble. So while doing so, what we found that multimodal ensemble performs better than any individual model. But again, there is need for human intervention. So what I find, for example, we did this during cyclone Mocha. If one particular model is outlier, it is providing forecast which is not consistent with other models, that is removed, and that is not considered in the multimodal ensemble. Similar was the case with respect to cyclone Biparjoy. So two models are suggesting that it will go towards left, and so we neglected that model. Another model is suggesting that it will go to east coast of India. So by that towards southwest coast of India. So by that, what we do actually for every run of the model, we discuss each and every model and remove the outlier and go for the multimodal ensemble of the remaining models. That, of course, at present is the simple mean. We will be going for weighted mean afterwards over these models. With respect to the second question, that which model even then is the best, we did a study, I think 5 years back, I did that study. It is published in TCRR. Among all the models, ECMWF performed better. ECMWF forecast of track was better. But if you look at this year, for example, that what I want to say that model performance also varies from year to year. This year, if you just look at the intensity performance, intensity forecast by ECMWF model was quite bad. It was always underestimating the intensity of the cyclones. But the point is that if you are monitoring regularly, you are in touch with various types of models, then you can find out which model is performing better. So what we do actually, we consider historically best model, and also we consider the best model for this particular season, and also the particular cyclone in which. So accordingly, what is given, and this is therefore the subjective expertise that also plays a dominant role in deciding the models and their combinations. Thank you.
Thank you for excellent answer.
Okay, I think we can.
Thank you, sir.
Yeah.
Now I request Ms. May Kin Chaw from Myanmar to please present the vote of thanks.
Madam, can you hear me?
Yes, please.
Yes, please.
Yes, thank you. Good afternoon, distinguished delegates. I'm making job from Myanmar, the embassy of Myanmar. It's my privilege to propose vote of thanks to all the participants on behalf of WMO ESCAP panel on tropical cyclones. I extend my sincere thanks to the invited speaker, Dr. Mohapatra, for this splendid talk on evolution of tropical cyclone, monitoring and focusing over the North Indian Ocean. As Dr. Mohapatra highlighted, the improvements in various components of early warning system since 1960, including observation, modeling, forecasting, and warning products generation and dissemination over the years. All these led to reduction in death toll to double digits over the entire region due to any cyclone over the northern Indian Ocean. Dr. Mohapatra has played a vital role in improving the cyclone warning services in the region. The guidance and advisories from RSMC New Delhi have been very useful for the effective management of the cyclones over the regions. Moreover, for example, during the previous extremely severe cyclone, Nestor Mocha, which hit to our Myanmar coast in May 2023. At that time, RMC New Delhi and DMH continuously contact with WhatsApp and exchange the informations, and RFMC supported to issue early warnings as well as guidance and advisory. Therefore, on behalf of Myanmar DMH focusing team, I would like to thank RMC and its team for this successful work done. I also thank WMO and ESCAP, who played a vital role in establishment of a panel on tropical cyclone in 1973 that has saved the region from the barriers of cyclone over the region. Special thanks to Dr. Pen, WMO, and Dr. Sanjay Kumar Srivastav for joining us. We also express our sincere thanks to all the members of PTCs and representatives from PR of panel member countries who attend gracing this occasion. My special thanks also goes to all the Malaysia researchers, academicians, students, and general public for their active participation. Finally, with this, we conclude and we solicit cooperation and coordination among all the participating members to establish a robust mechanism to combat disaster due to cyclone. Thank you. Thank you very much to all. Thank you, sir.
Thank you very much. Thank you. So we can have a group photograph.
Okay. We can.
Yes, sir.
We request all of you, please switch on your video. Chandan, are you taking the photograph? Komal and Chandan. Thank you, everybody.
Thank you. Thank you.
So
Thank
with
you.
that, we can. Yes, thank you.
Thank you, Madam. Yes.
Special thanks to all the distinguished delegates from WMO, from UNSCAP, from PTC member countries, from disaster management agencies from India, including the representatives from Indian Navy, Indian Coast Guard, offshore industries, National Disaster Management Agency, representatives from Government of Gujarat, Chairman CROPC, Mr. Sanjay Srivastava, forecasters from meteorological agencies from member countries and from IMD, researchers and academia. Thank you to all of you, and special thanks to Dr. Mohapatra for sharing with us the story of evolution of various components of early warning system in the value chain that has enabled the disaster management agencies to achieve the remarkable zero death toll over Gujarat during cyclone Biparjoy. We also want to thank Dr. Mohammad Shamim Hassan Bhuiya, Bangladesh Met Department, and Ms. May Chin Chaw, DMH Myanmar, for their active participation and support in organizing this session. So thank you to all, and we'll meet again next Monday with another special lecture at the same time. Thank you.
Thank you.
Thank you, ma'am.
Thank you.
Thank you.
Thank you.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Very much.